Discussing the topic is energy stored in a capacitor. Energy stored in a capacitor. This is the one of the important topic. Okay. Energy stored in capacitor. Energy stored. See the stored means what is the energy? There is a potential energy. The amount of work done by any body, some store of energy, that is called the potential energy. Here also the capacitor stored energy, see, that is in form of a potential energy. See, let us consider uncharged capacitor. What is considered as an uncharged capacitor? Means it is not connected with a battery, that is called as the uncharged capacitor. Now uncharged capacitor of capacitance, what is considered by the C, and charge on this capacitor is Q, but potential V is equal to 0 because of it is not connected with a battery. So consider uncharged capacitor, uncharged capacitor of capacitance C. What is the uncharged capacitor of capacitance is the C. The potential will be equal to 0. Will be equal to 0 means it is not connected with a battery. Now after that, this uncharged capacitor is connected with a battery. Now battery of the symbol, what is there? Is positive is the large line, the negative will be the short line. The capacitor will be have the same, two lines are will be same. This battery of EMF we consider the E, and its capacitance is C, and charge is V, and potential on capacitor, how much is considered by the C when it is connected with a battery. See, if the capacitor is connected to the battery. Now what is the connected by the battery with potential difference? Potential difference is V. Potential difference is how much is there? The V. And charge how much is there? The Q. And capacitance how much is C. Now when it's connected with a battery, it is the charging. Now what is there is a charging. Now the condenser is start to charging. Therefore average potential. See, average potential. See, what is the average potential? Initial how much is the potential is equal to is there 0. The after when it is connected to the battery, now it's a charging. When this capacitance can be charging, how much of the potential is there? V. Then it's the average potential between the initial and after. This is V average is equal, initial is 0 and after is the V by 2. Therefore the V average is equal to how much is there? Is a V by 2. This average potential how much is it? V by 2. When it is connected with a battery, it is a charging. The charging means some work is done. See the amount of work done. What is it? The amount of work done. The amount of work done between the plates. See, what is the work done for the formula? The work is equal to what again? Potential into charge. Since we know the potential is equal to work done by unit charge. Then the work done we can write here the potential into charge. Here the charge how much is there? Here the Q is the charge, V is the potential. The what is the potential is that is an average potential. Which are the potential taken by this average potential. Now this average potential V is equal to how much is there here? The V by 2. Then the work done is equal to V into Q by 2. V into Q by 2. See, we can write here the therefore the store of some energy, the work done, the work is stored, the work is stored in form of potential energy. Potential energy, it is denoted by letter is the U. Then we can write the W is equal to, since here therefore W is equal, what we can write the U, then the U is equal to Q into V by 2. See, this is the formula for the energy stored in a capacitor. Here the Q is equal to, what is here the charge, V is equal to potential difference. Potential difference. This is the one of the formula for the what is the energy storage capacity. If what is the formula, charge is equal to capacity into V. If charge is equal to capacity into V, then this value you can substitute here. So what will be changed? The U is equal to now C into V by 2, that is equal to 1 by 2 CV square. 1 by 2 CV square. And this is also another formula of a energy stored in capacitor. Next, if we can write here the V is equal to, C is taken there, the V is equal to what we can do, the Q by C. Q by C. Now again this V value substitute in this equation. Now what will we are getting by there? U is equal to, already is there the Q, in V plus what we can the Q by C. The Q into Q square. It is a Q square by 2C. Now these three equations, this is the first one and the second one, it is the third one. These three equations also energy stored in a capacitor. That's why you can the three equations similarly can the U is equal to QV by 2 or is equal to half CV square or is equal to Q square by 2C. Now these three equations is also is what is called the energy stored in a capacitor. But yes, observing the first equation, here the charge with respect to potential. The charge with respect to potential difference. And the second equation, what is there? The capacitancy with respect to potential difference. And third one is there the charge with respect to capacitancy. That's why it's a common expression. What you can the U is equal to QV by 2 half CV square and is equal to Q square by 2C. This is say the energy stored in a capacitor.